This is Bhumi Joshi from TE Electronics. Today I am going to explain experiment number 8, applications of precision diode using op-amp in LTspice software. So in this experiment there are total 3 parts. We will see it one by one. In first part we will see basic half-wave rectifier and modified half-wave rectifier. So here as you can, this is a circuit of basic half-wave rectifier. It is a very simple circuit. So let us understand how the rectification is done using this circuit. So whenever the positive half cycle is applied, then diode D1 will conduct and we will get output same which we have applied as input. And in negative half cycle we will get output as 0 because if negative voltage is applied to the diode, then it will not conduct and diode will be short circuited. So let us understand this operation with the help of simulation. So this is my circuit for basic half-wave rectifier. Here I am giving sine wave as 0.3 volt, frequency as 500 Hz and resistor as 1 kilowatts. So now let us run this circuit. So as you can see, this is my input wave which is of 0.3 volt and this is my output. So I am getting my output only when positive. I am getting my output only in positive half cycle. In negative half cycle I am getting 0. So this is a basic half-wave rectifier. Now let us see modified half-wave rectifier. So this is a modified version of half-wave rectifier. In this case there are 2 diodes. So whenever input voltage is greater than 0, then this diode D1 will be off. So because this is off, D2 get activated and we will get our output as 0. And whenever the input voltage is less than 0, then D1 will be turned on and D2 will be turned off. So we will get output as our input voltage. So now let us see modified half-wave rectifier. So here this is my circuit for modified half-wave rectifier. So here I have applied 0.4 volt and my frequency is 50 Hz. Here this 2 are my diodes and this 2 are resistor which is value of 1K. So now let us run. So as you can see, my input voltage is 0.4 volt sine wave, and as a output I am getting in positive half cycle I am getting 0 volt and in negative half cycle I am getting my output which is same as my input. So in this way part 1 is completed. So now let us start with our second part, which is full wave rectifier. So as you can see, this is the circuit of full wave rectifier. Here 2 op amps are used. So whenever we are applying positive half cycle to this op amp 1, we will get output as negative. So because of this negative output voltage of op amp 1, D1 will be in forward bias and D2 will be in reverse bias. this negative output is provided to this second op amp with the help of this R4 resistor. So this op amp 2 will act as inverting amplifier. So at the end final output we will get positive half cycle only. So basically whenever we are applying positive half cycle to this full wave rectifier, we will get output as a positive half cycle, and whenever we are applying negative half cycle to this full wave rectifier, we will get as a output positive half cycle, because this op amp 2 will act as inverter, uh, will act as inverting amplifier, so it will invert the output of first stage. So now let us understand with the simulation. So this is my schematic for full wave rectifier. So as you can see, this is a similar circuit. This is my two diodes. This is my inverting amplifier. Here I am applying sine wave as of 0.5 volt and 500 hertz. So now let us run this and see the waveform. So I'm applying input as 0.5 volt and I'm getting output as this. So as you can see, in positive half cycle also I'm getting output positive, and in negative half cycle also I'm getting my output as positive value. So in this way second part is done. So now let us start with our third part, which is clipper circuit. So this is a clipper circuit. So during the positive half cycle, output of this first this op amp will be negative. So the diode D1 will conduct, and because of this diode, output will be same as our input voltage. This will continue until the Vin is less than V reference. So whenever Vin is greater than V reference, output of op amp will be positive. So positive voltage is applied to this D1, so it will get turned off, and as output we will follow the same as input. So now let us see this with the help of our simulation. So as you can see, this is a positive clipper with positive reference voltage. So this is a positive clipper because it will clip output in the positive side, and we can easily identify because diode is in reverse direction. So here I am applying sine wave of 0.5 volt and V reference of positive 0.2 volt. So now let us run this. So this is my input signal and this is my output signal. So as you can see, my output is clipped, output voltage is clipped at 0.2 volt, which is my V reference volt. So now let us see positive clipper with negative reference. The only change will be we have to apply negative V reference. Now save this. Now I will run this schematic. So now this is my input voltage of 0.5 volt and this is my clipped output. So as you can see, in positive in negative V reference, my output will be clipped in the negative part. So in this way, positive clipper is done. So now let us see negative clipper. So this is a circuit of negative clipper with positive V reference. The only change is the direction of diode. So now let us run this circuit. So this is my input voltage, which is 0.5 volt, and this is my output voltage. So as you can see, my output is clipped from 0.2 volt. So now let us see with the negative reference voltage. The only change will be minus sign. So now let us run this. So as you can see, this is my input wave and this is my output wave. So output is clipped at 0.2 volt. So in this way, third part is completed. Taken the readings for various frequencies for half wave rectifier and modified rectifier also. So as you can see, this is a basic half wave rectifier waveform for 50 Hz. This is for 500 Hz. We have already seen this waveform. This is for 1 kHz. This is for 5 kHz. As you can see, whenever I am increasing the frequency, my output get more distorted. So at 20 kHz, it will give me this way. So this is my modified half wave circuit, as we have already seen. This is my output waveform for 50 Hz. This is my output waveform for 500 Hz. We have already seen this output. This is my output waveform for 1 kHz, for 5 kHz, and at the end for 20 kHz, my output is distorted. So now let us see full wave rectifier for various frequency. So this is for 50 Hz, this is for 500 Hz, 1 kHz, 5 kHz, and 20 kHz. So as you can observe, in both the three cases, whenever my frequency is 20 kHz, I am getting distorted output. So in this way, my explanation part for practical number 8 is completed. Thank you.